This lesson is a crash course in trigonometry. All of the big ideas that I think will be helpful for you when you're taking the AP test, things that you may have forgotten from trig in pre-calculus, or trig in geometry or wherever. So we're going to start with the unit circle. I think the unit circle is a fantastic model to have in your mind as to how to understand trigonometry and how to evaluate trig values like, tangent of 3 pi over 4, things like that. So let's start off with the unit circle. To start off going around, we'll talk about radians and degrees, but radians are what we're typically going to use in calculus. So right here, positive x-axis, positive y-axis. So on the positive x-axis right here, that is an angle of 0 radians, 0 degrees as well. As you move around the unit circle, up here is at 90 degrees would be pi over 2 radians. So pi over 2 radians. Remember, halfway around the circle is pi radians. 3/4 of the way around is 3 pi over 2 radians. And then all the way around is 2 pi. So this is also 2 pi radians with 360 degrees. The way I like to think about this is every 90 degrees is pi over 2. So this would be 1 pi over 2. This would be 2 pi over 2, pi. This would be 3 pi over 2, 3 pi over 2. And then this would be 4 pi over 2. 4 pi over 2s, that simplifies to just 2 pi's. Okay? So good kind of model for thinking about it because it scales to like pi over 3, for instance. So if you want to know where, as long as you know that pi over 3 is 60 degrees, for example, then you know that 2 pi over 3, that's 2 pi over 3's, is 2 times 60, which is 120, or 4 pi over 3's. 4 pi over 3 is 4 pi over 3's, which is 4 times 6 is 240 degrees. Anyway, the other thing that we do with the unit circle is we pick the unit circle to be let me start over. The unit circle is a very special circle because it has a radius of 1. Okay, so this point right here on the xy plane is the point 1, 0. All right, and if we pick an arbitrary point on the unit circle, say maybe right here, we'll call that point x, y. And if we lay in a right triangle onto the circle, wow, nice triangle, make the dot bigger. All right, this angle right here, we can call theta. This being a right triangle, this means that the sine of theta is going to be y, that's the height of the triangle, divided by the hypotenuse, which is 1. So we can write this, that sine of theta is equal to y, right? And we can also write the cosine of theta is equal to x over 1, which is just equal to x. Right, so this x comma y, this point right here, can be rewritten as cosine of theta, comma, sine of theta. Okay, so that's an important thing about the unit circle as well. Let's see, oh yeah, the other thing is, for when it came to tangent, is we define tangent as the slope, that's by the way, we define tangent as the slope of the line that's created when you connect the origin to any arbitrary point on the unit circle, right? So the slope is rise over run, so y over x. So we can write this, that tangent is equal to y over x. Well, that's just sine over cosine. So if you're someone that always flips around the sine and the cosine, can never remember which one goes over which when you're trying to remember tangent, just remember it's the slope, and that sine is y, cosine is x, so y over x is sine over cosine. Okay? There was something I thought about when I was talking about tangent. Oh yeah, so that makes it easy to solve certain tangent problems. So for instance, if you want to know what the tangent of pi over 2 is, and you can never quite remember where tangent is when it doesn't exist, because there's asymptotes in the graph of tangent. If you can never remember that, just remember that if it's the slope, it's wherever the line is vertical in the unit circle. So tangent of pi over 2 will be undefined. And tangent of 3 pi over 2 will also be undefined because the slope is vertical there. And tangent of 0, tangent of 2 pi, is going to be 0 because it's undefined. Oh, excuse me, because the slope of the line is 0. Right? So some tricks for not tricks, but some ways to think about tangent, right? Other things that I recommend students remember. You should remember that the special right triangles, and there are two of them that show up all the time. The first one is the 45, 45, 90 triangle. And 45 degrees in radians is pi over 4. By the way, you should remember that pi over 6 is 30 degrees, pi over 4 is 45 degrees, and pi over 3 is 60 degrees. Those things should be also seared into your mind, as well as pi, pi over 2, and so on. Right? So, if we set the sides here to be 1, 1, and if we set the legs to be length of 1, then the hypotenuse has to be the square root of 2 by the Pythagorean theorem. And if we look at a 30, 60, 90 triangle, boy, that's a bad triangle. Sorry. Here's pi over 6. Here's pi over 3. In other words, 30 degrees and 60 degrees. We set the short leg to be 1. The hypotenuse is twice the length of the short leg, so that's 2. And then by Pythagorean theorem, we can figure out that the long side of the leg should be square root of 3. And we can scale these triangles. So the ratios never change, right? Every 45, 45, 90 triangle is similar to every other 45, 45, 90 triangle. So this triangle can be scaled to, in this way. So if we let the legs be x, so any length, then that means that the hypotenuse will be scaled up by x as well, or scaled down, depending on what x is. But that will be x times the square root of 2. So if you double the length of the legs, so 2 and 2, 2 and 2 here, then your hypotenuse would be doubled as well, 2 times the root of 2. Okay, same thing down here. You can translate this generally to be x for the short leg, 2x for the hypotenuse, and then x root 3 for the long leg. Again, this is pi over 6. Oof, bad pi. This is pi over 3. Okay. So that is super helpful to remember for the AP test as well. I'm gonna erase the board. We'll do a couple examples and we'll call it. All right, let's do a couple examples here. So sine of pi over 2. Again, if we have this information about the unit circle memorized, this is not a difficult problem, because we can just think, well, where is pi over 2 on the unit circle? It's right here, right? It's 90 degrees. So here's pi over 2. What's the sine? Well, if I have this memorized, then I know that sine of pi over 2, the angle, is just whatever the y value is. Well, what's the y value? Well, this point right here is the point 0, 1, because it's left and right 0, so 0 on the x, and then up 1. So sine of pi over 2 has to be 1. Right? Check out cosecant of pi. Cosecant of pi, any of the reciprocal functions, cosecant, cotangent, and secant, if I have to do them by hand without my calculator, I'm going to turn them into the non-reciprocal functions, right? So I'm going to change this to 1 over sine of pi. So now I just have to figure out what sine of pi is. And sine of pi, let's see, so pi on the unit circle is here. Sine is the horizontal, sine is the vertical height of the point. There is no height here. In other words, y is 0. This is the point, negative 1, 0. So y is 0, so what I have is 1 over 0. Oh, what's that's undefined. So cosecant of pi is undefined. All right. Let's take a look at another one here, sine of 7 pi over 6. So this is where thinking about knowing that pi over 6 is 30 degrees helps you figure this out with the location of this angle quickly. So 7 pi over 6 is 7 times 30, that's 210 degrees. And of course you could convert, you could multiply by 180 over pi, and that would get you the same answer, but you gotta do some simplification. You might need to pull out your scientific calculator. But if you just think about it as 7 times that just being 30 degrees, so 210. So, this is making my drawing really ugly here. So start here, 90, 180, 210, something like this. So your reference angle is 30 degrees here, or pi over 6. So that tells you that you're going to use the 30, 60, 90 triangle to analyze this. What it also tells you is that sine of pi over 6, in other words, the vertical height at 7 pi over 6, the sine value here is going to be whatever the sine of pi over 6 is. It's going to be the same value as the sine of 30 degrees, with the exception, possibly, of a negative sign. If sine is negative in this quadrant, then the original function will be negative as well. The original problem will be negative as well. Okay, so let's do math here. So sine of 7 pi over 6 is going to be the same as sine of pi over 6, with the exception possibly of a negative sign. So let's figure out what sine of pi over 6 is. Sine of pi over 6, I would use my 30, 60, 90 triangle, which I should have seared into my mind, and I would figure out that sine of that angle is going to be the short leg over the hypotenuse, which is 1 over 2. So sine of pi over 6 is 1 over 2. So we do that little scratch work, and then we check, is sine positive or negative in this quadrant? Well, sine is in quadrant, or this angle is in quadrant 3, and here the sine value would be negative, right? Because sine is the y value, it's below the x-axis, so sine of 7 pi over 6 must be negative. We know that the actual distance is 1/2, and we know then that the location is negative 1/2. So this has to be negative 1 over 2. Right? And that's the first part of trig day.